Hello, it's your favorite chemistry tutor, Fan Joe. Now, let's take a look at this topic, E and Z isomer. Now, this topic is relevant to 200 level students offering chemistry, CHM 202, and for pharmacy students taking PharmChem 202. Now, E and Z isomer, where is this coming from? You can remember your stereoisomerism. Under stereoisomerism, we have two types. We have the optical isomerism, then we have the geometric isomerism. Under the geometric isomerism, you remember we have what we call cis and trans, and we also have what we call E and Z. So E and Z is coming from geometric isomerism. Now, E means antigigin, they are names of scientists. Then the Z, which is the Z, means zuzame. Now, E and Z isomer, cis and trans, they are applicable to alkene. I mean C double bond C. They are applicable to alkene. Now, how does this work? E and Z isomer works on the principle of Can-Ingold-Prelog rule. Now, this Can-Ingold-Prelog rule, most times you see it as CIP, works on the principle or rule of what we call priority. Priority given to elements based on their atomic number. Is that okay? So let's take a look at this compound and determine if it is E isomer or is Z what isomer. Now, firstly, working on our Can-Ingold-Prelog rule, what you do is that you pay attention to the olefinic carbon. These are the olefinic carbon, the C double bond C. These are your attention should be here. Now, what you then do is that you address each of the olefinic carbon one by one and give them the substituent on it. You give them priority. The substituent here, the substituent here, you give them priority. Which one comes first and which one comes second? Now, you move to the second olefinic carbon. These are the substituents here and the substituents here. So between the two of them, which is giving the first priority and which is giving the second priority? That is all you are going to be doing here. So let's go back to it. According to Can-Ingold-Prelog group, priority is given based on their what? On their atomic number. And how do we go about that? All you do is that the element that is directly attached to your olefinic carbon. In this substituent, the element that is directly attached to our carbon is what? Oxygen. And that is why you have to be very, very careful because of structure. Because this HO can be otherwise written as OH. Now, if they put OH here, you should know as a chemistry student that this oxygen here was the one directly attached to what? Carbon, not what? Hydrogen. So we are paying attention to elements that is directly attached to our olefinic what? Carbon. So in this case, oxygen is directly attached to the olefinic carbon of this guy. Then at the other side here, what is directly attached is what? Carbon. Now, what is the atomic number of oxygen? 8. What is the atomic number of carbon? 6. Now, based on Can-Ingold-Prelog rule of priority, oxygen 8, carbon 6. Which one is giving the highest priority? Oxygen. Why? Because 8 is bigger than what? 6. So, meaning that this guy should be given 1, while this other guy here, the whole entity here, the whole thing here should be given what? 2. Don't forget, what we pay attention to is the element that is directly attached. Oxygen is directly attached here, carbon is directly attached here. So we are done with that. Now let's go to the second guy we have here. Now, you should be able to look at this, the second olefinic carbon. Everybody pay attention to the second olefinic carbon. Now, to this second olefinic carbon, what is directly attached? I want you to check it yourself. We have carbon directly attached in this case. Can you see carbon here? So we have carbon that is directly attached, carbon. Then at the other side also, you can have two substituents. You can see the two substituents. At the other side also, we also have what? Carbon. So we have carbon here. Now in this case, there is a tie because carbon and carbon is the same. 6, atomic number 6. There's a tie here because they are the same. And because they are the same, what else do we do? What you do according to the Can-Ingold-Prelog rule is that you move to the immediate elements. We are moving to the immediate elements. And how do we do that? Very simple. If you have to move to the immediate elements, this is carbon. The immediate elements after this carbon is nitrogen. So nitrogen is the immediate element, but there's a rule that you have to pay attention to here. You can see that here we are having triple bond. Anytime we have a double bond or triple bond to a particular element, if you have a double bond to a particular element, that particular element will be duplicated. But if you have a triple bond, the elements will be tripled. What do I mean by that? In this case now, N is directly attached to carbon, but there's a triple bond here. Because of this triple bond, our nitrogen will also be tripled, meaning that in this entity here, our nitrogen will be 3 times, and the reason is because of this triple bond. So meaning that if I have C double bond O, my oxygen will be how many? 2. I think you are getting that clear. In the case of, can you see C double bond O? So I was saying, what if you have C triple bond C? If you have C triple bond C, it means your C here will be 1, 2, 3. Please pay attention to that. So anytime we have triple bond or double bond to a particular element, you either triple it or you double it. But in this case, we're having a triple bond to N, meaning that because our after the carbon, the immediate element after the carbon is nitrogen. But because of the triple bond, we are making our nitrogen triple. We're having 1, 2, 3. Now let's move to this next guy here, because we have carbon here, we have carbon here. So the next thing is to move to the what? Move to the nearest what do you call it? The immediate element. So the immediate element here is nitrogen. Now let's consider the immediate element here. This is COOH. The way you can understand this better is if I can draw out the structure of what we have here. This C double bond. This is alkanoic acid, which is otherwise written as C double bond OH. I believe you all know that. So this is our carbon here. This is the carbon here. There's a tie at the carbon. So we are moving to the next immediate element. So what are the elements that is directly attached to this carbon? Who can pay attention to that? We can see that it's directly attached to O, and it's directly attached. It's a double bond O. So we have single bond O and a double bond O. So in this case, anytime you see a double bond, what did I say? Double bond to a particular element, the element will be double. Triple bond, it will be tripled. In this case, we are having double bond to O, meaning that we have O, another O. That's because of this. So double bond O means O and O. Then this is also connected to oxygen. This is also connected to oxygen, making it how many like that? That's 3. So we have this double bond O gave us this. Then it's directly attached. So in this case, we have O, oxygen, and in this case we have what? Nitrogen. Now in this case, we want to declare the winner. Now who wins between this entity and this entity? Very simple. You know that nitrogen, the atomic number of nitrogen is 7. This is 7, this is 7. Why? We know that this is 8, this is 8, this is 8, that's the atomic number. Now based on that, very simple, just compare. Once you have a particular element that is higher. In this case, we have oxygen. Oxygen is higher than any of them. Because oxygen is higher, then it means that this guy will be given priority. So in this case, this is number 1 and this is number 2. Why? Oxygen has more priority than what? Nitrogen. Now let me give you another kind of scenario. What if you have something like this? O, H, and H, and we have N, and N. What if we have this condition? Now it's very simple. Because we have oxygen is 8, though this is 1 and 1, this is 7, 7, 7. But because we have a particular element that is bigger, having higher priority, in the case of these two, who are we going to declare the winner? Who are we going to declare having more priority? In this case, this guys here is having more priority than these guys here. And why? Just because this first component here is having oxygen. Oxygen is more than all of them. As simple as that. I think that is clear. For example, if I have nitrogen, or let me say, let's bring another one in. Let's say we have O, we have H, and we have H, and we have C, we have C. Because of this oxygen that is present in this component here, this is giving more priority than this. Is that clear? Because oxygen is more 8. So is having more priority than this. So thank you. Now in this case, this guy is having priority, and in this case, so in the first olefinic carbon we have here, this is where our priority is. This is the priority. And for the second one, in the second olefinic carbon, where is our priority? This is our priority. So priority is here 1, and priority is here. Is that okay? So when is it E, and when we have it as what? Z. Z means Zusammen. Zusammen means same side. Zusammen, same side. Are you getting this? While entgegen means opposite side. So in this case, you can see that it is far apart. It is opposite. This is opposite. Opposite, like a trans. Opposite. Is that okay? Because it's opposite. Anytime it is opposite, it is E isomer. But if the two priority are on the same side, if they are on the same side, we call it what? Z. But in this case, because they are not on the same side, this is here up and this is here. If you take a look at it, the priority here is, this is where we have our priority here. You know, this one was oxygen, this one was carbon. We give priority to this guy. This is the priority on this first olefinic carbon. On the second olefinic carbon, we got this to be our priority. This is one, this is one. So these are priority. So if it's going to be E isomer, it means that they are transverse to each other, or they are far apart. They are not on the same side. You can see this one, at this olefinic carbon, we have it up. At this olefinic carbon, we have it down. So they are not on the same side. But in the case whereby the two of them are on the same side, let's say we have this here, and this other one was also here on the same side, we can call it, when it's on the same side, we say it is what? It is Z what? Isomer. So, but in this case, they are in opposite side. You can see that one is up here, then the other one was down. So can you address this question? Can you try this yourself? C double bond C. I want somebody to try this question. C double bond C. Let's see somebody who can do this. Let's say we have CN here, we have BR here, we have C double triple bond C H here. Then we have, let's say, so easy, so easy, so easy. Let's make it easier. We have OH here, then we have CN here. Try this. I want to know if it is E isomer or a Z isomer. Thank you so much. Ensure you subscribe to our YouTube channel. This is